Hello, I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are starting a new series for all the students in high school to learn about calculus. Calculus, as you know, is one of the most important subjects taught at high school level. It basically deals with differentiation and integration. But to do these two things, you have to put in all your learnings. So a lot goes into this particular subject, which can be a very good foundation for any university level curriculum. Now, you should learn from me this particular topic since I do have a wide experience of about 15 years teaching students here. But the most important thing here is that we begin with a very concise diagnostic test. Now, just with 10 to 15 questions, we are able to understand what you exactly need. And based on your need, we plan a success path for you. Now, this success path, you will travel with me with my videos and test papers from previous 10 years. That makes a lot of sense, right? So why not taste a class from Anil Kumar and join the lessons. Before starting calculus, we'll take up what are the prerequisites, and the topics will be selected based on the results of the diagnostic test. We'll touch upon the algebraic skills which you need and a lot of function related things as shown here, right? So we'll look into the details of what you missed while learning functions earlier in your grade 10 and 11 curriculum. Once you have this good foundation, we'll begin with the calculus, which starts with limits, differentiation rules, rate of change, optimization questions, and so on. Enjoy the journey and succeed with me. Thank you and all the best.
I'm Anil Kumar. As a pilot project, I'm starting a new series for students taking calculus in grade 12 or first year university. We'll also include students who are taking IB Math grade 11 because they start calculus in grade 11. You may subscribe and include email ID to participate actively and get future updates. All my videos are and will be free on YouTube. Now the idea here is that students taking calculus sometimes need extra help. I'm ready to provide you with that. But I want to restrict the group to, let us say, 15 students. You'll be encouraged to post your questions and I'll, within 48 hours, answer them in details so that you understand all the concepts. Now to begin with, what I'm doing here is sharing with you some previous test papers. Test papers always help us to prepare better. So this one is of an IB student. You can actually copy these questions, work them out. I'll take some of them in this series also. Here's the next one, correct? So let me see the other side of this test paper. So we have two more questions here. Basically, this one is on rate of change and instantaneous rate of change. Now, these are very important topics. And in diagnostic test, we always see such questions. Now, here's another test paper where you may have to find equation of the function given or possible zeros, or this is also instantaneous rate of change. Now, these test papers are for the students taking calculus, and immediately in the very first week there will be a diagnostic test, right? So this is all you should know before starting calculus. That's the whole idea, right? So let's take another one. Here are a few more questions. Rationalization is a huge topic. You should be fairly good at it. Then of course you have seen rate of change is another very important topic for you to understand before getting into calculus. Now here are a few questions on functions. So rational functions, piecewise functions, to sketch functions, right? So, and then here is another test paper. This is all from the very first quiz or test, where they are trying to figure out what you understand even before starting calculus, right? Rationalization is a very important topic, and of course rate of change, instantaneous rate of change. Now the last question here is actually very difficult and a very good question. So I'd like you to make a note of these questions. You can go back and forth, copy these questions, and do them even before the semester starts for calculus. So in this new series, I'm going to start with the diagnostic test. From the previous test papers, I've made my own questions, which I'm going to answer one by one in this particular series. So I have a set of 15 questions. Here are first 4. You can always pause the video, copy them out, and then we have the next 4, right? And then question number 9 to 12. So these are based on functions, and then we have 3 questions based on rate of change, right? So I hope you have copied them all. You should try them out. Take this as a diagnostic test. Now let's begin answering them one by one. So here's the very first one. Question number 1 is, a linear function is given by y equals to 5 minus 3x. If x increases by 4, how much does y change? Well, this is the simplest question in the series. We have y equals to 5 minus 3x, which is a linear equation. Now it says, if x increases by 4, how much does y change, right? This question is based on simple context, simple formula, but still it is tricky. So when you're doing calculus, you have to think a bit. Now here we are saying if x increases by 4, how much does y change? So basically we are given change in x, which is, let's say, delta x is 4. We need to find what delta y is. And as you know, slope, which is rate of change, normally you write m in the equation y equals to mx plus b, gives you ratio of this, right? So m is change in y over change in x. Now from the given equation, you know the slope is minus 3. So you could always write this as minus 3 equals to change in y over change in x, which is given as 4. Now if you cross multiply, you get minus 3 times 4 equals to change in y. So minus 12 is the change in y. Do you get an idea, right? So you can say that how much does y change? Y change by minus 12. So that's our answer. So y decreases by 12, or you can say changes by minus 12. You get an idea, right? So that is how you can answer this question. So it may look simple but interesting, right? So let's move on to question number 2. Now let's do question number 2. It is to simplify 2 plus h whole cube minus 8 over h. You can always pause the video, answer the question, and then look into my suggestions. Now let me rewrite this particular expression. We are given 2 plus h whole cube minus 8 over h, right? Now I could write this as 2 plus h whole cube minus 2 cube, right? Whole cube minus 2 cube over h. Now I hope you remember the formula. What is a cube minus b cube equals to? A cube minus b cube is a minus b times a square plus ab plus b square, correct? If you have a cube plus b cube, then we get a plus sign here and a negative sign there. Now in this particular case, we have to use difference of cubes, where a is 2 plus h and b is 2. So if we apply the formula, what do we get? So we get the first factor as 2 plus h minus 2, and the other factor as square of 2 plus h. Now we use minus, we'll use plus here. Product of these two, that means 2 times 2 plus h plus 2 square. That's what we get, correct? So let's expand it over h, of course. So let's expand it. So we have simplified this one. So we have only h here times 2 plus h whole square, where let me write this as, I could write 4 better, okay. 2 square plus 4h plus h square plus 2 times 2, 4 plus 2h plus 4, correct? Over h, over this h. So they cancel away. So what you see here is that this h in the denominator cancels off. And whatever is there in this numerator, you can simplify this, correct? So 4 plus 4 plus 4 is 12. So we get 12. Let's open the bracket. Then as far as h is concerned, 4h plus 2h is 6h. And then we have the term h squared. So that is what we get. So normally in calculus and also in rate of change, you must have seen this kind of formula which is applied for rate of change. And at times we assume that h is very, very small as compared to 1. So if you neglect this value, we get 12 as our result. Now it has a lot of significance in calculus, which we will learn as we move forward, right? So I hope the concept is very clear, a straight application of difference of Q formula. Now let's take up the next question, which is rationalization. So now you have to rationalize numerator. We are given square root of 5x plus h minus square root of 5x over h. So let's rewrite this first. Square root of 5x plus h minus square root of 5x over h. Now rationalization really means to multiply and divide by its conjugate. And what is the conjugate? Conjugate, we have to just change the sign and multiply. The whole idea is that a plus b times a minus b is what? Is a square minus b square. So when you square root, you get something without radical. So that helps you to simplify. So that's the idea. So you simplify many expressions involving radical signs by rationalization. So that's a very important technique to learn. So the numerator will be difference of squares. So you get 5x plus h minus 5x. And in the denominator, I'm sorry, I wrote it wrong. It should have been 5x plus h square root plus square root of 5x. I'm sorry. You have to multiply and divide by the same thing. So it is multiplying by 1. So what you get here is h times, let me write within square root, within square brackets, square root of 5x plus h plus square root of 5x. Now the numerator, 5x and 5x cancel. We get h over h times square root of 5x plus h plus square root of 5x. Now h and h cancels. So what you get here is 1 over square root of 5x plus h plus square root of 5x. Now rationalization really helps. You can see in the given expression, if I say that h approaches 0, then what do we get? We get something like this. That the numerator, which is 5x plus h minus square root of 5x over h, approaches 0 over 0, which is undefined, correct? However, if in this expression I use the term x approaches 0, h approaches 0, then what do we get? We get this expression as equals to 1 over twice square root of 5x. Do you get an idea, right? So that really helps us to simplify our expression and also find some values when we are approaching that means some value. So it will have a great significance in calculus, and that is the reason why I have taken this up as question number 3, and it is also a test question in many diagnostic test papers. So let's move on further. Here is question number 4. Simple factoring. Factor 3 times x to the power of 3 over 2 plus 6 times x to the power of half minus 9 times x to the power of minus half. Let me rewrite this. You need to factor 3 x to the power of 3 by 2 plus 6 x to the power of half minus 9 x to the power of minus half. Do you see that? You need to factor this one. Now, it may be difficult for some students since we are using radical signs here. So in factoring, you haven't really done such question up to now. Well, let's first group factor 3 itself because 3 is a common factor. Now what should we factor from x? If you see the powers of x, minus half is the lowest power. So we could factor minus half, correct? So as far as numbers are concerned, 3 divided by 3 is 1. Now what should I get here? It should be x to the power of 3 by 2 minus whatever this power is, which is minus half. Do you see that? So it gets added up. Okay. Now the next term is 6 divided by 3 is 2. X to the power of half minus half, correct? And the last term will be 9 divided by 3 is 3. X to the power of minus half, which we actually factored out, but let me write minus half, correct? This is what you get. Now let's do our math. So we have 3 x to the power of minus half within brackets. What is 3 by 2? Let me rewrite this. 3 by 2 plus half. Do you see that? Plus 2x half plus half minus 3x to the power of minus half plus half, correct? So we get 3x to the power of minus half. Now 3 by 2 plus half is x to the power of 4 by 2 plus 2 times x to the power of half plus half is just 1 minus 3x to the power of minus half plus half is 0. Now when you say 3 to the power of x minus 2, you could have written this also as 3 over square root x. Is that okay? Minus means 1 over x and square root. Now here, what do we get? 4 divided by 2 is 2, so you get x squared. In this case, it is 2x. Anything to the power of 0 is 1. You get minus 3. Now that is a quadratic expression. You could always factor this one. What you get? You get 3 over square root x times. We are looking for product of minus 3, correct? So we need two numbers whose product is minus 3 and whose sum is plus 2. Well, 3 and 1 will work. So, but 3 should be positive. We need plus 2 as their sum and minus 1. So that is how you could factor the given expression. So I hope all the steps are absolutely clear. Now in calculus, we have to really work with the radicals. So you should be good at factoring such radicals, right? Now let's take one more before I close the part 1 of my video. Then I'll do part 2 and 3 to take the rest of the questions, right? So here the question is, determine possible zeros for the function f of x equals to x cubed plus 3x squared minus 4. Now, let me remind you of remainder theorem, if you know that. Or even factor theorem, both are related. Well, you must have learned in polynomials, correct? So when you're looking for zeros for a polynomial, I've taken a very simple example, just x cubed. It could be to the power of 4 or 5, all right? So to factor this, we look for possible factors. Possible factors are factors of the constant here, which is 4. So the possible factors could be plus minus 1, plus minus 2, or plus minus 4. Now, if 1 is a factor, that means if I divide by x minus 1, the remainder is 0, right? Factor theorem says that you find the value of the function for a given number, and if the remainder is 0, remainder is the value of the function. If the remainder is 0, then it is a factor. So let's substitute 1 here. So if I substitute 1, I get 1 cube plus 3 times 1 square minus 4, and that is 1 plus 3 minus 4, which is indeed 0. Correct? So that means x minus 1 is a factor. Now since x minus 1 is a factor, I could do long division. So I could do a long division here, dividing x cube plus 3x square. Since we do not have x term, we'll write 0x minus 4 by x minus 1. So if I do that, well, let's divide by x square times. We get x cube minus x square. I hope you remember the division. Okay, so it gives me 4x square plus 0x. Now I could multiply by 4x. So that gives me 4x square minus 4x. When you take away, you get 4x minus 4, and that goes 4 times. And therefore, I could write the given expression. Let me rewrite. F of x as equals to x cubed plus 3x square minus 4 as equal to x minus 1 times the quadratic function x square plus 4x plus 4. You get an idea, right? So we have factored the given expression. Now this can also be factored. You know, it's a quadratic equation. It's a perfect square. So we could write this as x minus 1 times x plus 2 whole square. Do you see that? So that's easy, kind of, not so difficult. Anyway, so we got this factored, but the idea is to remember factor theorem to factor polynomials, right? Well, if you try what is f of minus 2, you should get 0, right? If I write minus 2 here, you do get 0. So that's the other factor. So that is how you should be factoring polynomials, and that's a technique which you should always remember. Now here is question number 6. Write the interval minus 2 to 6 as an absolute function inequality. Now we are saying that on a real number line, we're looking for x between minus 2 and 6, not including these numbers, right? So we're looking for something which is within this, and this is from minus 2 to 6. So as an inequality, you can always write this as x is greater than minus 2 and is less than 6. Now the question is, write this interval as an absolute function inequality. So that's the question for you. How are you going to do it? Now let's try to understand absolute functions. When we say absolute function, we are interested in finding the mid value, and from there it should be same distance away. So this is the basic concept. So that really helps us to get the answer. So I think you understood the trick involved, right? So what we'll do here is we'll find the midpoint. So the first step is find midpoint. So midpoint will be minus 2 plus 6 divided by 2, and that is 4 divided by 2 as 2, right? So we get the center value here, which is at 2, okay, which is at 2. So this is step number 1. Second is, how far are you? So midpoint, find how far are you? How far away, right? That is the second thing. So that is, you can do 6 minus 2 is 4. You could also do minus 2 minus 2 is 4. So both ways, I mean the 4 distance away, of course this is minus 4. However, when we say how far away, we are talking about distance, right? We're talking about distance, which means absolute value, right? Which is always positive. So we normally write this in these terms: absolute value, and absolute value of -4 is 4. You get an idea, right? So we are 4 units away from the center 2. Now, will this help you to write down the inequality? Of course. So you move to point 2, that means absolute x minus 2 should be less than 4 units. So that becomes an absolute function as an inequality, which will represent this interval as its solution, right? You get an idea, right? If you solve this inequality, you get that as your solution. So this is how you can represent intervals in terms of absolute function inequality. Good concept to know as you move on to calculus. Now question number 7 here is to expand 2a minus 1 to the power of 5. Well, to expand this, I hope you remember Pascal's triangle. So you may need Pascal's triangle to expand such binomial expressions. So let me make one here. Let's say we begin from number 1 and we just move diagonally, right? Does that remind you of anything? Okay, so, and then we go like this. We add the previous 2. 1 plus 1 is 2. And then we further continue. So we get 1. 1 plus 2 is 3. 3. It is symmetric. You can see that, right? So it's easy to add numbers, do half of them. 1 and 1 always on the sides, correct? So when you add them, you get 4 and 6, 6 and then 4, correct? Now this is the 4th row. Then again we move on. Since we are interested in to the power of 5, we have to do 5 rows. This is 0th row. Is it okay? Then we come 1st, 2nd, 3rd, 4th, and now we are on the 5th row. So we get 4 plus 1 is 5, 4 plus 6 is 10, 10, 4 plus 1 is 5, and 1. So these are the coefficients when you expand this. And remember, whenever you expand a binomial expression, when you add their powers will always be same, 5, correct? So now it is easy. So we can now expand this, which is 2a minus 1 to the power of 5 as equal to. So the first term is 2a. So we have 2a to the power of 5 times minus 1 to the power of 0. Do you see that? So that is how you put the expressions together. Then let me write plus. Now this power will decrease by 1. And here we had the coefficient 1. Let me write 1 here. And then the coefficient 5. We write 5 here. Okay. And the first term, which is 2a, decrease the power by 1 and increase this power by 1. So when you add them up, still it is 5. Perfect. Now plus. Next is 10. So that becomes the coefficient of these terms. So I hope that's a good revision of Pascal's triangle application. You could always use the binomial theorem also, right? Minus 1 square. So 3 plus 2 is 5. Now let me add here. So we have plus. Next is again 10. And then we have 2a to the power of 2 minus 1 cube, right? And then 5. 2a to the power of 1 and minus 1 to the power of 4. Normally you should not be writing 1. It is well understood, right? Plus the last term here, which is 2a to the power of 0 and minus 1 to the power of 5. So, and normally you should not write 1 also. But I'm writing all this just to show you how it links with our 5th row, right? This is our 5th row. So 5th row gives you coefficients, right? Now we can rewrite. So 2a to the power of 5 minus 1, anything to the power of 0 is 1, 2 to the power of 5 is 32. So we can write this as 32a to the power of 5, correct? Now next term is 5 times, let me write 5 times 2 to the power of 4 is 16, right? So we get 16a to the power of 4, and this is minus 1, plus 10 times 2 to the power of 3 is 8, right? So 8a cube, and that is just 1, so I'm just leaving it away, even powers, right? Then we have plus 10 times 2 squared is 4, so 4a squared, and this is minus 1, right? Okay, so alternate terms are negative, that's why I'm keeping them. So 5 times 2 is 10. Let me write this as 10a, but this is positive, and the last term here will again be negative term. Anything to the power of 0 is 1, so I do get negative 1, right? So now let me rewrite the final answer. So we have 32a to the power of 5, and we can multiply these two with a negative sign this time, minus. So 5 times 6 is 30, and 5 times 1 and 3, 8. You will notice that till now we have done all the examples without calculator. So in diagnostic test, calculator may not be allowed. So selection of my questions are such that you could do without calculator, right? I forgot to tell you that earlier. So now we have 10 times 8, which is 80 a cube, and then we have a negative sign. 4 times 10 is 40, or 80, 8 times 10, minus 40 a square. And then we have the last term, which is minus 10a, right? Let me rewrite this. So we have 32 a to the power of 5 minus 80a to the power of 4 plus 80a cube minus 40a square minus 10a, right? So that's what you get as the expansion of 2a minus 1 to the power of 5. Okay. So I hope you recall the Pascal's triangle and understand how we could answer such questions, right? Okay. Now let's take up question number 8, which is determine inverse of the function y equals to x squared minus 2x plus 3, satisfying that f inverse of 6 is minus 1. Okay, so that should not be very difficult. However, there's a trick involved. So we have to find inverse function, right? So we need to find inverse of y equals to x squared minus 2x plus 3. And we are also given that f inverse of 6 is minus 1. Now how does that help? As you know, inverse of a quadratic function is not a function. So if you do some restrictions, it becomes a function. So basically, this is a restriction which will help you to decide plus or minus sign at the end. Okay. Now let's see how to find inverse of this function. Now whenever a quadratic function is given to you, to find inverse, we need to complete squares. Okay, only then you can find inverse. So first part we'll do complete the squares, and then we'll follow the steps to find inverse. So we have y equals to x squared minus 2x plus 3. To complete the squares, well, there's no coefficient. 1 is the coefficient, so the steps are simpler. So we get x squared minus 2x, half of 2 is 1, so we'll add 1 square and subtract 1 square. Is it okay? Now first 3 terms make a perfect square. In this case it is x minus 1 whole square, and we have minus 1 plus 3, and that gives us x minus 1 whole square plus 2. So that becomes the required function. Now to find inverse, what are we going to do? We need to swap x and y, correct? And then solve for y. So that's what we are going to do now. Let's do it here. So when you swap x and y, you get x as equals to y minus 1 whole square plus 2. Bringing 2 to the left side gives us x minus 2 equals to y minus 1 whole square. Now square root it. So square root x minus 2. You get plus and minus y minus 1. Bring 1 this side. 1 plus minus square root x minus 2 equals to y. Now at this stage, you have to look into the given condition. That is to say, this inverse should satisfy the condition that if x value is 6, y should be minus 1. So what will work for that? Plus sign or minus sign? Correct? So if I write 6 here, so let's test. So we are doing the test for x equals to 6. In this particular expression, what do we get? 1 plus minus square root of 6 minus 2. And that gives you 1 plus minus square root of 4, which is 1 plus minus 2. Now out of these, we get actually two values. One should be 3, the other one is minus 1. Since we are interested in minus 1, we'll choose negative sign. Is it okay? So since the point 6 minus 1 is on inverse, we'll use f inverse x as equal to 1 minus square root of x minus 2. Do you get an idea? So that becomes our answer. So it is not plus minus. Plus minus means it is not a function. We got two values. The question specified one, that f inverse of 6 is minus 1. So we'll select the domain of the function on the negative side. So that is a function. Is it okay? Now, as a question for you, you should write domain and range for f inverse. I should have written for f inverse x. Okay. So as an additional question, you can take up the same inverse function and write down domain range of the inverse function. Now let's continue with part 2, diagnostic. And if you have come so far, let me share with you that in this series, what am I going to discuss? So we'll do all these 15 topics. So we are beginning with diagnostic. We'll go to rate of change, limits, derivatives, implicit differentiation, applications based on velocity, acceleration, related rates, extreme values, curve sketching, trigonometric functions, exponential, logarithmic functions, antiderivatives, area under curve, basics about integrals, and we'll also take up questions based on IB, AP, AB calculus, and IIT JEE entrance examination, that is test questions. So that will really help you all to understand this topic or all the topics in calculus fairly well. So let's begin with answering question number 9, which is write the domain range of y equals to minus 3 square root of 16 minus x square. So what is this type of function? What does it represent? Well, if you need to sketch it, it will look like a semicircle. Minus means all values are negative, so it is going to look like this. Perfect. Now, when we talk about domain and range, let's look into the function in details. It is minus 3 square root of 16 minus x square. All this you're supposed to know, right? Now the idea is that within the square root, we should always have non-negative number. That is to say, 16 minus x square should always be greater than equal to 0. Correct? Now, that is to say that if this is greater than equal to 0, what is x? Well, you could say that x square, you can take it to the other side, is less than equal to 16. Perfect. Or x is between these two values, which are between minus 4 and plus 4. Right? Now, when you do square root, the idea is when you do square root, important thing here is to understand. Let me do one more step here. So at this stage, what are we doing? We are doing square root of a function. So you should know square root of x square actually is absolute value of x. And that is why we are saying that x should be between -4 to +4. The other way to look into it is that you could actually sketch this function, right? And then figure out which is a portion which is greater than 0, correct? So the alternate way look into this is like this. You could sketch this particular function, which is 16 minus x squared, correct? So if you sketch 16 minus x squared, what do you get? We're just sketching 16 minus x squared, nothing else, okay? That is to say, the function will be, you have to go 16 up and open downwards, correct? Like this. At x equals to 0, the value is, if I write x equals to 0, what you get here is 16, correct? Now, and the two zeros are at -4 and +4. So this interval between -4 and +4 is when the function is positive. Correct? So that becomes the domain of the function. So all this we did to check domain. What values can x take? Now, if you sketch this function, which is, let me say y here, x here, this value is -4, this is +4, and y is equal to this function. Because of -3, it like moves downwards. Now if x is 0, what is the value of this function? If I write x equals to 0, I get y equals to -3 square root of 16 minus 0, which is -3 times 4 or -12, okay, -12 or equals to -12. That means this value is -12. Now with all that information, you can always write domain and range. So let me write down the answer. Domain of this particular function is x belongs to real numbers, where x is greater than equal to -4 and less than equals to +4, correct? As far as the range is concerned, range is y belongs to real numbers, where y is between 0 and -12. So y is greater than equals to -12 and less than equals to 0. So that is how you can get domain and range of such functions. So as a part of diagnostic, you should actually look into many other examples with combination of functions as we've taken up here. Now let's look into question number 10, which is based on piecewise function. The question here is, find a and b such that the function is continuous. You can always pause the video, answer the question, and then look into my suggestions. Now if you check the function, we know -x is continuous. This is a parabola which is also continuous. This is constant 6. It is also continuous. Now when we say this function is continuous, that means we should check at these boundaries, right? At -2 there is a possibility of discontinuity, and even at 0 there is a possibility of discontinuity. To make the function continuous, we should check at -2 and at 0, right? So what happens when x is equals to -2, and what happens when x is equal to 0? So those are two very critical values. So these 2 points, these are 3 different pieces. Function is continuous when they overlap, correct? So when f of x, if we substitute x as -2, what do we get? So we could get from the first leg, which is this one, we are saying that its value should be x is -2, so we'll write x as -2 here. We get -2, is it okay? And from this portion, when it is greater than -2, it should start from the same place, right? So if I substitute minus 2 here, I get a times minus 2 square plus b. Now that gives me an equation, 2 equals to 4a plus b, right? On the other hand, if I substitute 0, now 0 links these two pieces. They should overlap, right? So if I substitute 0 here, I get, so we are substituting 0, we get b here. And if I substitute 0 here, well, it is constant 6, b should be equal to 6. So from the second condition, it is clear that b is 6. So if I substitute b equals to 6 here, I can find the value of a, right? So substituting b equals to 6, we get, let's do it this side. Substituting b equals to 6 here, we get 2 equals to 4a plus 6, and then we can arrange 2 minus 6 is 4a, or this is minus 4 divided by 4 is a, so the value of a is minus 1, correct? So for continuous function, we get our answer that a should be equal to minus 1 and b should be equal to 6. Only then this piecewise function will be continuous. Otherwise, it will not be continuous, right? So I hope with this you understand piecewise functions and the rule for continuity. So the idea is these two pieces should overlap and these two pieces should also overlap. Let's take one more question to end up part 2. And this question is, identify the intervals of increase and decrease, symmetry, asymptotes, and behavior, and domain and range of the function given to us. So in part 2, we are discussing mainly functions. Okay, so let's rewrite the function, which is g of x equals to x cubed over x squared plus 1 whole square. Now, I hope you remember the strategies which you've learned to sketch a rational function. So those will help you here. So I'll not get into great details. You may have to review those things, right? So when you're taking calculus, you should know all of them. But anyway, let me give you key features here. So first, let's look into zeros. So what we see here is that we have a 0 at, we have to say x cubed equals to 0. That means x equals to 0. So we have a 0 here, correct? Then we can look into vertical asymptotes. So vertical asymptotes in this case is when denominator is 0. That is x squared minus 1 equals to 0. And that gives you x is equals to plus minus 1. For both these values, it will be 0. So let me just sketch vertical asymptotes here. For greater details, you can always look into my videos on sketching rational functions. Okay, now we can look into horizontal asymptote. Since the degree of denominator is 4, 2 times 2, perfect. So you add them up, 2 plus 2, as I should say. And numerator is 3, that means degree of denominator is higher. So we have a horizontal asymptote at y equals to 0. So that is your horizontal asymptote. So let me just show it here in a dotted line. So we are more worried about the extremes. Now, with that and some more information, you can always sketch this particular curve, right? So to make things simple, what I will do is I'll take some value. So let us take value of function at on the left side of minus 1. So let's say minus 2, okay. So what we get here is in the numerator we get minus 8, and in the denominator minus 2 becomes square, so 4 minus 1. It is always positive. Do you see that? Denominator is always positive, so numerator decides the sign. So when you are on this side negative, you will get negative quotient, and you know this is a vertical asymptote. So without doing many calculations, I will just sketch it. So what we get here is a function which is kind of like this. Similarly, I could say, well, on the positive side, it should be like this. So I'm not really getting into details, but kind of giving you hints to sketch. This is cubic 0, right? So that means it should be kind of like this. And let me just go with the asymptotes. So this is the expected function. Now this is a very important function. You will also see that the graph of the function crosses horizontal asymptote. Do you see that? Some students think that asymptotes cannot be crossed. Vertical asymptote you cannot cross. That is a restricting domain. However, you can always cross horizontal asymptote. Anyway, let's write down answers for these. So take your time to answer all these. Intervals of increasing and decreasing, symmetry, asymptotes and behavior and domain range of this particular function. Now let me answer symmetry first for you. So when we are talking about symmetry, we really want to figure out what is g of minus x. So if I write minus x here, I get minus x whole cube over minus x whole square minus 1. Everything is squared. And this gives me minus x cube. And the denominator is exactly as it was before. But it is negative of our function. So we could write this as minus g of x. That means what? This means odd symmetry, right? Now you can see from the graph that it is symmetric about origin. So it does have odd symmetry. Okay. Now let's write down answers for all these parts. So let's say increase. When is it increasing? It is increasing in between, right? So between minus 1 to plus 1. Decrease. When is it decreasing? From minus infinity to minus 1 and from 1 to infinity, correct? Symmetry, odd symmetry. That is how you prove it, right? Since g of minus x is minus of gx. Asymptotes we have already written. End behavior. So end behavior means when x approaches minus infinity, y approaches what? It approaches 0, but from the negative side. And when x approaches positive infinity, y again approaches 0, but this time from positive side. So that's the end behavior. Domain and range. Okay, so domain is x belongs to real numbers. However, restriction is that x is not equal to plus minus 1, and range is y belongs to real numbers. Is there any restriction? Well, the graph crosses the origin, that is the x-axis. So all values, is that okay? So that's the range for the given function. So I hope with this example you have understood a greater part of functions in part 2. And I hope this series is helping you to recall what you learned so far and how useful it will be in doing calculus.